I was not in this room yesterday, so I don't know. Trying.
Test, test. Yeah, it's working.
So I can introduce you, or you can just start if you want me to introduce you.
Yeah, why not?
How do I say your name?
An Andre. Andre.
Andre.
Yeah, exactly.
Are you taking questions at the end?
Yeah.
Okay.
hmm
So you want me to? How many minutes are you gonna have for the questions?
Maybe 5, 10 minutes at the
Okay.
end.
So I can give you like a 10-minute mark at
Yeah,
when
yeah.
10 minutes is at the end, and if you
Yeah,
want to
and
start
after
some
that,
questions.
give me please 10 minutes, and after that, just to wrap this up, because I have a lot of sections, and maybe I will not cover them all. But after, when I will have only 10 min 10 minutes, I can jump to the end, because I have some links, and after that, I can finish the presentation
10
properly.
minutes before 10-minute Q&A, or 10
Yeah,
minutes,
10 minutes before. mm,
5-minute Q&A. So I
yeah,
give you like a
5 minutes.
15-minute mark before
Yeah,
the end.
yeah, it's
Okay.
fine.
Okay. Sounds good. Good morning, everybody. Welcome to the security track at SCaLE 21. Our presentation is the open source fortress, and our presenter is Andre.
Hey, hey, good morning, and thanks for joining. I'm Andre, and we will spend 1 hour together for talking how we can find vulnerabilities in software using open source tools. I want to mention that if you have any question during the presentation, please feel free to interrupt me and we can discuss. Let me start by a bit of context about myself. I started an open core startup 1.5 years ago with a bunch of friends. And after working on it, participating in different programs for startups, we decided to stop it because of lack of traction in the open source space and business space. And this also come with the decision to leave the previous job that I had, which was in the army, in the Romanian army to be more precisely. And this is the photo that I had from the last day in the server's room. After that, I was lucky enough to enter Canonical in the Ubuntu security track for securing the distribution. This is a photo with my team in Bilbao, in which we participated in the Linux Security Summit and a physical sprint together. At the same time, thanks to Alex Murray, I started doing short sections in the Ubuntu Security podcast for detailing academic papers. So if you want to hear that out, just give a try on Spotify or whatever podcasting platform you prefer. So let's deep dive into the content. Uh, Open source implies the code is open, namely anyone can read it. And this also assumes the ability of an attacker to read the code and to detect vulnerabilities and to exploit any instance that are set by anyone on the internet. But in my opinion, this doesn't need to be this way. We already have some open source tools that we can install and detect these vulnerabilities before the attackers, namely in a shift left approach during the during the development of the code. Um, and this will also minimize the risk of publishing vulnerable software on the internet. And let's start with an example, which is for Roundcube. Roundcube is a browser-based IMAP client, and as in their websites, it provides full functionality you expect from any email client, for example, Outlook or Gmail. Uh, this is a graph with their GitHub stars just to get a grasp of the adoption of the tool in the open source space. You can see that there is a steady increase of the stars, so the software, in my opinion, is widely used in practice. And you can also judge this Shodan query. For anyone who doesn't know this, Shodan is a search engine for computers on the internet. You can create a query, run the query, and after that, Shodan will provide you a list with all hosts on the internet that will match the query. So by using this simple query, namely http.component roundcube, we can see that there are 161K hosts on the internet. So this somehow proves our previous assumption. After that, we can look at what programming languages do we have for this code base. And what I did here is just cloning the repository, changing the directory into what I already cloned and running SSC into the current folder with a head. And we can see the top programming languages in this code bases, and there are PHP, SQL, JavaScript, HTML. If anyone here has a home lab, maybe this is familiar for you. This is the web installation page for Roundcube. And basically, you can plug a lot of details in your browser, and this will be stored in the server. What happens here, it's detailed on this diagram. Basically, we have the user, which configures the Roundcube instance through the user interface. The raw user-controlled configuration is stored on the internal configuration. And after the initial configuration, if anyone sends an email with a non-standard image, then we should get the path to the conversion program, which is set in the initial configuration. And we need to execute Roundcube exec for converting that image into something that Roundcube understands. So basically, we have two main flows here, one for installation, one for email processing, which is basically the vulnerable one. And I want to ask you if you have any idea what's missing here, judging by this raw user-controlled configuration. Yeah, that's right. And any other aspect that's missing? Input sanitization. Maybe it's not important enough that the user is not authenticated, but we also have the problem of the input not being sanitized. Namely, any command that is executed here in the last execution path is basically user controlled by anyone on the internet. So an attacker can send a post request to the installer. You can see there an im convert path with a PHP command, which is for a reverse shell. After the attacker sends an email containing an image with a non-standard format, for example, TIFF, that Roundcube doesn't understand by default, Roundcube will try to convert the image to JPEG using the command that was provided when configuring the instance, which is the parameter of the im convert path. So in this way, the attacker will have a reverse shell. Basically, anyone from the internet can scan for hosts, can send this kind of requests. After that, can send an email with a non-standard image and get reverse shell into these instances. This is known as CVE 2020-12641. There are multiple configuration items as the one that we previously saw, as im convert path, which led to arbitrary code execution into the instance. The CVSS for this vulnerability was 9.8. It has an exploitability score of 8.1, which is pretty high. So basically, if you have a vulnerable Roundcube instance on the internet, there is a high probability of you being exploited. And as previously saw during the last year, this was also used by APT28, which is this advanced persistent threat actor, a huge name in the bad guys scene, which compromised Ukrainians' organization servers during the Ukrainian-Russia war. And it was also added by CISA, which is this American organization, into their known exploited vulnerabilities catalog. And then the question is, was this preventable? What do you think? Yes, it was, but there is a but, not with standard linters and scanners. As you previously saw, there are some functions, for example, Roundcube exec, that, for example, Bandit or CPP check or any other linter will not understand by default. This is basically the vulnerable function, which doesn't do the input sanitization that we previously mentioned. And you can see there, for example, after that command, executable must exist, that if that check will pass, then the command is returned as it is, basically the raw user control configuration, without any shell escape, let's say. One possible solution for this is taint analysis. We will discuss this in a following section. Uh, Basically, we will track the execution flow using this source of data, namely roundcube get instance config, and we will set a sink, a sensitive sink, namely, hey, if this data will end up into this sink, for example, an argument into a function call, then we have something sensitive in there. There is something named semgrep, which is this code querying engine. We will discuss this in the presentation. And this is a rule, a YAML rule that is created for semgrep for detecting this vulnerability. We basically set the source using a pattern with the function and the object that we previously mentioned, the sanitizer that must exist in order for data to be sanitized, in this case, escape shell command, and the vulnerable sink, which in this case is return. And if we run this rule, the semgrep rule over the function we saw before, we will have two matches here. Basically, the returns of command without any sanitization function called. So what I want to detail today is the open source fortress. There is an internet-facing website in which the whole presentation and the workshop that backs this presentation are. There is basically a collection of open source tools that you can proactively use to detect vulnerabilities in your code bases. And there are multiple sections here, namely factual information about software security topics, and the brief presentation for each analysis technique, and some practical examples, namely some exercises that you can do at home for testing these tools on your own. This presentation will cover only the bolded items in here. I hope the quality of this is good enough. Judging by the smiles is not, so let's take this one by one. We basically have there as the first step threat modeling. Namely, we need to think about how an attacker can attack our application. After achieving this process, we will have a threat model. For example, if we have a login page, we can think, hey, maybe anyone on the internet can brute force this. There is a threat there, so we should consider this in later development phases. After that, there are two branches here, one for manual vulnerability detection, namely myself as a security researcher will do some manual steps in order to detect the vulnerabilities in that code. And the other approach, that is the bottom branch, is for automated vulnerability detection. And here we have multiple steps. The first one is running the tool and aggregating the results. After that, we have triaging, namely seeing what warnings are invalid or not. And after that, in the end, we end up with some vulnerabilities that are coming from both processes, namely the manual and the automated one. For the second one, for the second approach, you can also think about a CI/CD pipeline in which you have some quality gates. For example, hey, after each PR that I receive for my code base, I'm running a lot of linters and security scanners for seeing if that commit is vulnerable or not. If it's not, I'm merging the changes into the main branch. After having these vulnerabilities, we have two approaches. Either to execute the defense activities, if, for example, the code base is ours, either to attack the code base if we are a malicious person. For defensive activities, we need to research the vulnerability. For example, if you have experience with AFL or any fuzzer, you can detect crashes. Basically, some blobs of data which doesn't mean anything. You only know that the program is crashing, but you have no further context. So in this step, you basically need to take the crash, to take the data that is crashing the application, and do some research in order to understand why your application is crashing. This also contains CVSS approximation. You can see there a string. Basically, there are multiple components for computing a score between 0 and 1, which is the severity of the vulnerability. And this is, for example, for log4j. And you can see here in the end something like CH, IH, IH, which is configuration impact high, integrity impact high, and availability impact high. Beside this, we have CWE, which is basically a classification of the vulnerability. In the case of log4j, we have this CWE, which is 502, which stands from deserialization of untrusted data. You'll have the presentation afterward. The links are clickable, so you can deep dive afterward. And we should also request a CVID. For example, if I'm the maintainer of OpenSSL, let's say, I want the users of my library to be concerned and to update their libraries. So what I'm doing is to publish this CVE, which is basically an identifier and a bunch of information about the vulnerability itself. In the case of log4j, there is this unique string that may be well known for many of you. And other defensive activity is patching. For example, this patch that is linked here from Oracle, communication with stakeholders, and this is the remediation guide from Apache. And as previously mentioned, you can also do offensive activities. For example, if you want to write a malware, and this is not something that I'm proposing, but this is something usually done by state actors, by anyone wanting to spread the malware in the wild. And there are multiple steps here. You need to write an exploit. You need to detect an attack vector. For example, we can continue the example for log4j. Here you can target VMware Horizon instances and exploit log4j. You can bypass mitigations, and here we have two TTPs, which are for symmetrically encrypted channel communication and mimicking legit services. Again, there are links in the presentation for afterward. And weaponization, an ID for a TTP. And the exploitation part, in which you basically run the exploit over instances on the internet. But we will look today at Ubuntu Portrait, which is a vulnerable by design code base, like WebGoat, like then vulnerable web app, like CloudGoat, any vulnerable application that is written to be vulnerable by default. Basically, it's a lightweight piece of software that runs on an Ubuntu server and allows users to control it through their browsers. I written this from scratch. It contains a lot of vulnerabilities, and basically we will look at multiple techniques in which we can detect vulnerabilities in the code base. It should be deployed on premise, and it's written in Python and C. So most of the tools are specialized on these two programming languages. There are 12 plus embedded vulnerabilities, and there is a plus there because the application depends on Python packages. As you know, vulnerabilities appear during night, so maybe there are multiple vulnerabilities appeared in the meantime. Let me show you how this looks. Basically, here we have a login form in which I used the PAM credentials. I want to upload the file in the server. I'm clicking some buttons, and there is also a functionality for exploring the file system. And I'm showing you this to provide you an idea about what's the application about, and just to let you think about what can go wrong with this application. For example, you've seen some a way to execute commands. What if we can run commands which are not embedded in the sandbox? Uh, this is the architecture of the application. Basically, we have a web UI which does API requests through HTTP to a backend, which hosts a web API in Python 3 and Flask, and it also connects to a shared object written in C for generating recovery tokens, and the Linux authenticator for checking if the provided credentials are valid or not. Nice. So the first technique for detecting vulnerabilities, or a proactive step, let's say, not really to detect vulnerabilities, but to catalyze the action of detecting vulnerabilities, is threat modeling. And this is an image perfectly illustrating what threat modeling is. We have some assets, which is the food on our fridge. We have a threat for our assets, which is the cat, which is trying to get the food. And threat modeling means being inspired enough to assume that the cat will want to steal the food from the fridge. So, as previously mentioned, it means identifying the assets and the threats. So you should answer to these questions for your code bases. What we need to defend, what can go wrong, and I should mention here that this threat modeling activity is already a legal requirement in some states, for example, USA and Singapore. Not all states are adopting this at the moment, but in my opinion, this will be the future. And there are multiple advantages for this kind of approach for threat modeling, namely to design a secure by default solution, to prioritize your activities, and to boost the confidence of your stakeholders. Because as you see, some states are requiring this, so they want to have confidence in the solution you develop. The first open source tool we will look at is OWASP Threat Dragon. Here is a quick demo for Threat Dragon. I'm creating a threat model here. I'm already using something existing, but after clicking the existing model, I can see the architecture items, for example, the circles and the rectangle on top, and some details on the bottom for explaining what each component does. And the red lines over there are existing threads. For example, I have an authentication path, something there may happen wrongly. So I should think about that and plan for some mitigations. So the usual process for this open source tool is creating a threat model using a diagram style. In this case, in OWASP we have Stride and CIA. We need to represent our assets, which means which can be stores, processes, actors, data flows, and trust boundaries, and to manually identify the threats which are possible with type, status, course, priority, description, and mitigations. There are, for example, some commercial tools which automatically identify the threats which are possible. For example, hey, I'm using these AWS components, I'm linking these two together, what can go wrong? And the tool will automatically detect the information without you being required to do this manually. Do you remember this image? Any metrics fan here? No? So there is this search scene in metrics, and this is an illustration for the next vulnerability detection technique that we will look at, namely code querying. It means searching for a specific pattern into our code base, and there is an optional abstract representation of the code base, for example, as abstract syntax tree or control flow graphs. There are multiple query types in here. You can search for literals. For example, I'm searching for scanf, but basically I can have, this is a dummy approach. Basically you can have scanf into a comment and it will also match. You can have regexes, and basically I'm writing here some parentheses for detecting the calls. This is still dummy, but I also have some data structures. and there is a tool called Journ, which has a specialized kind of query language. And after creating an abstract syntax tree, it provides me the ability to query that tree. So I can write here CPG, which is the graph, that method, and I can search for scanf, and after that, all calls. And the advantage for this technique for code querying is that you can have community queries, which are generic, but they can help you detect some vulnerabilities for which you are not aware of. This is an example of an abstract syntax tree. This is what a computer or compiler will understand. So we need to think about ways in which we can query it. For this, we have semgrep. The installation process is pretty straightforward. Just pip install semgrep. After that, we need to write this kind of YAML rules. There is the first example regarding Brown-Cube. There is this one for detecting all login calls to logging or logger using some passwords or tokens. So we are trying to detect all passwords or tokens which are logged by the application, which, as you assume, it's a vulnerable pattern. We should not do this in our code bases. After that, I'm running semgrep with the scan functionality. I want to export the results into the serif format, which is something proposed by Microsoft for standardizing the results of static analyzers. I'm mentioning the configuration path, where should I store the output, and what's the code base. In my case, there is the portrait application, the one which we described 5 minutes ago. After running the tool, I can see that 17 files were scanned, and that there are 9 findings, namely 9 vulnerabilities in this code base. And this is a snippet from Ubuntu Portrait in which, in fact, the user and password were logged after authenticating a user. You can also test this at home using semgrep and the code base of this workshop. What is semgrep? It's a partially open source code scanner. I'm saying here partially because they are an open core startup. They have an open source solution, but they also provide some pro feature for which you should pay for. It supports 30+ languages. There are no prior build requirements, and in my opinion, this is a huge advantage. You have, for example, Coverity, but Coverity has this disadvantage that you should build firstly your code base, and after that to run the tools. For semgrep is not the case. It's basically scanning the code, and that's it. And another advantage for semgrep is that it has no DSL. If you remember the Journ query, you have seen that there are multiple weird names that are combined, and after that you have the query. For semgrep, if you want to query, for example, Python code, you'll write Python code in the end. So it's low barrier to entry. And the advantage that was previously mentioned, namely it has default rules, basically a default configuration that you can use for scanning your code bases, but you also have third-party rules, which are written by members of the open source community that you can take and run on your code bases. The next technique, another classic here, guesses? Idiocracy for 2005, in which people are dumb enough to not being able to solve this kind of games. And the question here, what if we can have the same approach, the same dumb approach for our programs and testing our programs? And this is what fuzzing does. Namely, hey, let's run the program using some random inputs and see what happens. In this case, a crash in the program is basically a security issue. This may or may not be the true statement. For example, we can catch null dereferencing. We can have sanitizers as address sanitizers, undefined behavior sanitizers for increasing our success rates. And basically, it's a BFS traversal of the control flow graph. And there are multiple optimizations here for running our code faster, which is instrumenting the code or, yeah, uh, knowing the input format, which are helping the fuzzer to do a better job. This is the architecture of a fuzzer, but we will not deep dive into that. Maybe leave it for home. And as an open source tool for implementing fuzzing in your code bases, you can use AFL++. There is a straightforward installation. You basically need to run the Docker image and that's it. And this is a harness, namely some code that we should run beside the code of the application for gluing the fuzzer and the code base. And you can see here that we have a file that is read, basically the file that is produced by the fuzzer, and in the end there is a call to generate recovery token, which is the function that we want to fuzz. So basically we run that function using two arguments which are generated by the fuzzer. This is how we can run AFL. Firstly, we need to compile our program with using AFLCC. It's an alternative for GCC or CLang or whatever you use that basically implements or instruments the code base in order for the fuzzer to do a better job. We also include the symbols using the -g flag. We specify which is the executable that we should produce, which is crashmeifyoucan.alv, and the C source files which are used for as input. After that, we run the fuzzer, which is AFL fuzz, with a -i flag for specifying some dummy inputs. For example, if we want to fuzz a parser for images, we can provide some example images for the fuzzer to better understand the format, -o for specifying where the output should be stored, and in the end, the executable that we should fuzz, and a symbol for specifying where the fuzzed data should be placed. So as an argument in this case. We run the program, and we can see that after some milliseconds, there is the first crash. You can look at the findings in depth section, and there is a total crash number, which is 1. And this is the code that triggered the crash. And you can see here that there is a buffer which has a fixed size in which we copy the data which are specified when calling the function. So basically, this is how we can use a fuzzer to detect vulnerabilities in this kind of complex code, which is, in my opinion, hard to audit manually or hard to understand if you are not the writer of the code base. So this was a demo for AFL++. It's a fork for American Fuzzy Lab. And it has, besides AFL, some additional features, which are QEMU emulation, persistent mode, which help us to create snapshots of the process and run the program faster and faster, and other optimizations. And it's nice that Google already embedded this tool into OSS Fuzz. So if you are a maintainer, just a short introduction here, if you are a maintainer of an open source tool into a memory unsafe language, you can basically create a PR for OSS Fuzz for integrating your application into their fuzzer, and they will allocate the Google infrastructure to fuzz your code. So basically to detect vulnerabilities using in your code, which is pretty nice, and there are a lot of huge projects in the open source space which are already leveraging this, and they have nice trophies, nice vulnerabilities which we're detecting with this approach. Another technique for finding vulnerabilities is secret detection. And there was, I'm Romanian, in fact, and we had this habit for hiding our keys under our mat, which is really insecure. Basically, a thief can look under the mat and detect the keys. And we try to transpose this approach, namely finding the keys under the mats in computer science into development. And we have here secret scanning. There are multiple types of secrets into a code base. We have API keys, we have credentials, we have tokens. These are sensitive items which should not be included in your code base. You should use, for example, environments variable or standard input or whatever you prefer, but not including them into your Git repository, let's say. This approach means scanning for a specific pattern or for entropy, for a secret, and as for the case of code scanning, we have here community or generic rules. For example, there are some rules which are created by the community for scanning for AWS tokens. You can import these for your code base and run them, and that's pretty much it. There is low effort. For the practical part and the next open source tool we will look at, we will download the release for Git leaks. You basically need to enter their GitHub and click the release tab and download the binary for your architecture. The run is pretty straightforward. Just use this command that will specify where the source code is stored and where the results should be stored. And the last flag is for reducing the secrets. Basically, the results will not also include the secrets, only their location. After running this tool for multiple commits, we can see that there are 5 secrets which were leaked. And this is something for Ubuntu Portrait, the application at the first of the presentation, in which I included a secret key for Flask. This is hard-coded. I should have used, for example, I don't know, some random number generator that is present in my operating system, and not using this approach of having a hard-coded key. So Git leaks, it's a detector for hard-coded secrets. What's nice about this tool is that it's analyzing the entire Git history, so not only the current state of the code base, also the commits in the past, because, for example, you can have overwritten secrets. You may think that they will not exist in your code base, but in fact, someone from the internet can scan all commits and can detect them. And it also supports baselines and custom formats for secret. For example, if you have a custom API, and this is something that GitHub does, for example, they have a prefix, for example, JH underscore, and after that the secret. You can also have this approach for your secrets, prefix them with something, and after that create a pattern for a secret scanner, and in this way you can detect your custom tokens. And the baselines, what this means, these tools have maybe a high rate of false positive. So you can run the tool once, validate the warnings, and after that, consider all warnings as false positive. If you run the tool again, you will exclude the warnings which you already proved as false positive. So you only scan for the difference, and you should validate only a few warnings of the tools. I have this XACD meme for illustrating a chain of dependency, and I think you are already familiar with this because of PIPI, because of NPM. This is a graph that is generated for an NPM package. You can see the main package in the center, and after that there is a huge dependency tree for that dependency. Basically, if we have a vulnerability into one dependency, this will propagate in our code base. But it's nice that we have open source tool to deal with this, namely tools for dependency scanning. We basically iterate through all dependencies in our code base, and we try to find vulnerabilities in them. For example, CVEs which are published for Flask that we are using for creating our web servers. It's using a dependency declaration list, for example, a PyProject.toml or package.json in the case of the NPM ecosystem. And for this demo section, we will look at OSV Scanner. It's a tool created by Google. And yeah, as previously, the setup process is straightforward. We just download the binary from the releases from GitHub. We run the tool with this simple command. We just specify the poetry.log file, which is generated by Poetry, a package manager for Python. And we can see a bunch of vulnerabilities which are reported by the tool. I really think that this list increased in the previous few days, so this may be a bit updated. And you can see here the dependency list. In this case, I searched for CVE 2023-4863, which was a heap buffer overflow in libwebp, which was in fact used by this pillow library, which I had integrated in Ubuntu Portrait. OSV Scanner, basically there is a database published by Google, the OSV database, which embeds multiple sources, which are GitHub Security Advisories, PIPI, RustSec, and Global Security Database. And there is also support for ignored vulnerabilities. So if you can prove that a vulnerability doesn't apply in your code base, you can specify the vulnerability as false positive. Yeah. So Black Duck, if I remember correctly, is for composability analysis. So maybe the end goals are a bit different. But I can compare to Fossa. I know that they have some reachability feature which is pretty handy in my opinion. For example, they see that, hey, you are a dependent of this package, but we will also look at your function calls. Basically, if I'm using a vulnerable package, it doesn't mean I'm also vulnerable. I should call the vulnerable function from that package. So they are also doing this. Maybe we can expect some tools in the open source space in the near future for also implementing this. But yeah, at the moment there are only the commercial providers which offer this kind of features. The next section, I like the car safety or the automotive industry because they have these standards they should check for each car. Basically, they have a score, and based on that score, you can assume how safe the car is in an accident. So we have the same approach in our computer science industry for linting, which basically means defining some rules and do some static analysis for finding issues before compiling or running the code. And these issues may be formatting. For example, hey, you're using spaces and not tabs, or tabs and not spaces, whatever you use. You can also scan for grammar. For example, if a developer is not using inclusive words in the UI, you can basically automatically raise some warning for the developer to replace these words, or you can also have security warnings. For this demo section, we will use Bandit. Maybe this is really familiar for you, for Python developers in the room. It's already integrated in a lot of IDEs, but we will prefer the CLI interface. I'm using the recursive flag for scanning all source files. I'm specifying the path to the code base. I'm specifying the format, which is also serif. This is a common theme in my presentation. I like serif. It's nice about serif that you can also push the results into the GitHub security tab. So it's pretty straightforward, and you can have results into the GitHub user interface with the linters or security tools that you have set. And a -O for setting what the output file is. After running the tool, we can see this output, and um, there is this snippet from our code base from oops, test. Yeah, it's fine. So this is a snippet from Ubuntu Portrait. You can see there that I'm unarchiving a file, and this is a vulnerable pattern that is already detected by a lot of linters. So it's a low-hanging fruit that is fastly detected by an attacker, but can also be fastly detected by the developers, with Bandit in this case. It's a linter for Python. It has an abstract syntax-free representation of the code, and there are multiple modules in this tool. Basically, we have patterns for suspicious code. We have deny lists for imports or function calls. For example, if we want to block the pickle module, we can do this from Bandit. And it also have a report generating functionality if we want to pass the results to any other person. And it also has support for baseline, the functionality we already discussed. Another movie. Do you remember this? It's from Maze Runner. Basically, they are locked inside a maze, and they need to run inside the maze in order to detect all paths, and they need to escape the maze. And yeah, we can also think about how we can apply this abstract concept of having a huge problem space and searching it in computer science. And this is what symbolic execution does, and data analysis. We have the CFG, the control flow graph, basically the tree with all function calls in our code bases, and we replace the concrete values with some symbolic ones, and we search for some specific patterns. There are multiple components here. There are some sources, namely where the data came from, some sinks, namely some places in which some tainted data may end up, and we can consider this combination of sensitive sink and tainted source as a vulnerability, and some patterns. And we also have a path explosion problem here. Basically, some code bases are huge. It's really hard to explore all possible paths. We can miss a lot of vulnerabilities, but the guarantee of this approach is that we will explore all possible combinations in the end with, let's say, an infinite compute power, which is, yeah, not true, but it's still detecting a lot of vulnerabilities in projects. As a demo, we have SCaLE, which is an open source symbolic execution engine. Just take the Docker image, run it. As in the case for fuzzing, you need to write a bit of glue code. In this case, I'm marking some buffers and an integer, a symbolic, and I'm running the generate recovery token function again. I'm running the compilation phase, the engine, and in the end, I can see that I have an error there, namely an out-of-bound pointer, which is basically the error which was detected previously by fuzzing. So SCaLE, it's a generic symbolic execution engine with security use cases and built on LLVM. This marks the end of all security detection techniques, but there are others which you may use. There is stress and load testing. You can use JMeter for many protocols and services, or K6 for Kubernetes, and web dynamic analysis using OWASP ZAP. And we all like automation, so all this tool can also be automated. I will briefly mention some tools that you can use. There is Sarif multi-tool for performing operations with the Sarif files that we generated into this presentation. We have make and POI deployed for running the tasks. We have ID workflows, for example, something integrated in Visual Studio tasks for running the tooling while coding. We have pre-commit, for example, hey, run me this bunch of linters before uh, pushing the commit into the origin. And ACT and GitLab Runner for running CI/CD workflows locally. This is pretty useful for developing some or using the same code that you want to run on remotely on GitLab or GitHub, but locally. And yeah, the remote alternatives. I want to end this by mentioning the Ubuntu concept, which is, yeah, I guess you are familiar with the Ubuntu operating system, but we didn't invent the name. It's a South African philosophy and ethical concept. And I really like this quote from Nelson Mandela: Ubuntu does not mean that people should not address themselves. The question, therefore, is, are you going to do so in order to enable the community around you to be able to improve? So I want to end this presentation with some ways in which you can help the open source space. At first, you have some sponsorship options. There are a lot of GitHub projects with this button, namely sponsor. You can donate €1 or €2 monthly for the projects that you use. This means a lot for maintainers who are contributing their spare time for community, basically. You can also report bugs and vulnerabilities via email, GitHub issues, or any reporting channels that the upstream has. For example, just take a random code base from the internet, from GitHub, run the tools that I described on this presentation, and see what you get. Maybe there are some vulnerabilities that the upstream are not aware of. And lastly, you can implement some features or solve some bugs for security tools, or maybe you can propose some patches for the vulnerabilities you discovered in the previous approach. And in this way, I can bet that the whole community will be grateful for the work that you did. So I was Andrei. If there is a single thing to remember for this entire presentation, there is this link, which already contained the presentation, the workshop, the cheat sheets that you can use, and more. So the barrier to entry in this vulnerability detection space is pretty low, in my opinion. So you can go home and implement these features in a few minutes. Thanks. If
Towards the beginning, you mentioned a flaw with a round cube, and then you used SemGrep, static analysis tool.
Yeah.
I'm not familiar to show a way of detecting that, but you had to load like a custom rule. I use Coverity, and I'm fairly certain Coverity would just catch that without needing a custom rule. The open source version of SemGrep, does it have a more generalized rule that would catch that in other software?
So as previously saw in the code base, there are some custom methods which are called, right? There is, for example, the roundcube namespace, and there is this exec function inside the namespace. The linters and SemGrep will not detect this kind of methods by default, so you should specify them. In my opinion, the rules are pretty straightforward to implement. You need just to understand the format for these YAML files, and the open source engine is capable of using the tools that you generate, run the data flow analysis that I mentioned in the presentation, and combine this information and detect the vulnerability. This is something that I use in the practice. So you can use the open source engine with that rule and detect the root cause of the CV that we have seen. Does this answer your question?
So for me, the reason to use code scanners is so I can stand on somebody else's shoulders who's way brighter than I am because I'm stupid. These open source code scanners and all of this that you're talking about, are they actually maintained by people? Or do I have to go in there and write my own rules to try to figure out my own bugs? Are other people contributing? How active are these projects so that I can, look at this and I can say, look, I'm going to put this in my pipeline so that I'm constantly, getting other people's input and trying to build on their shoulders. Because if they're not, I'm just going to go out and spend the money to buy a commercial version of this because the security of my products depend upon it. So can you comment on that, on what you see as the activity on these various projects?
So the startup that I previously mentioned was for small and medium businesses. And a thing that I learned from that experience was that the small companies that doesn't have the money for the commercial solutions. For example, they can pay 1,000 for a security solution because maybe they have a marketing campaign that they should execute. So in my opinion, you can use this open source tools if you don't have the money or if your use cases are generic enough. To respond to your question, there are a lot of contributions. These tools are used by security researchers, by DevSecOps people, by DevOps people. So there are a lot of parties integrated in the community, which are contributing with their rules. I'm familiar with SamGrab. There are a lot of people pushing their rules into the open source space, either by using the hosted repository from SamGrab, or just create a GitHub repository and push the YAML rules there. So in my opinion, yeah, you can use Bandit, for example, just run the tool and you can have some low hanging fruits that you can catch. But if you have some really tailored use cases, maybe you can tailor the scanners, which are open source, or if you have the money, pay a provider to do this work for you. And you should also consider the fact that most of these tools, namely the static ones, so not symbolic execution and not fuzzing, are generating a lot of false positives. This issue seems somehow solved by the commercial companies, but we are still fighting this in the open source space. There are a lot of warnings generated by Bandit, by CPP check, by other tools, so you should invest the time to validate if the warnings are valid or not.
Yeah, just one follow-up question. So the one thing that I didn't see in here is the profilers, where you take your code and run it in a profiler and run your tests against it to make sure that you're actually, squirreling into all of the if statements and execution and stuff like that.
Are you referring to coverage or?
Yeah, code coverage, code coverage profiling.
Yeah, it's a nice recommendation. I will do this, in fact. So the workshop and the websites are work in progress. So it's a good idea. I preferred going to security tailored tools, namely security scanners, fuzzers, symbolic execution engines. But yeah, I agree that you can also use this kind of coverage analysis or profiling to detect the code paths which are not that executed, because if they are not executed, maybe people are not paying enough attention to these code flows. But the attackers may detect that there is a vulnerability there, and they may target that specific code flow. Yeah, thanks for the recommendation.
Okay, so I guess one of the questions I have is, you mentioned like going back to OSV scanner. How would you, like, projects like Yocto have tools for checking vulnerabilities, but they're using the CVE database instead, like CVE check. Would you recommend to one of those projects that they start looking at using this different database OSV scanner as opposed to like they're just checking CVEs?
they are also checking CVs, but it's nice about them that they are trying to integrate this vulnerability data under the same umbrella. They are doing this, for example, with RustSec. If I remember correctly, there is no direct correlation between a RustSec ID and the CV. They are not working for assigning a CV ID for each RustSec ID. So in my opinion, it depends on the project. If you have vulnerability data which is not available in CV or MITRE or NVD, you should also use alternative streams. Maybe there is OSV scanner, maybe there is another tool which is tailored for your tool chain.
Okay, so this Yocto is a distribution builder. I don't know if you're familiar.
No,
I don't
no.
know if okay. So you know, they're used for building embedded Linux distributions. It's pretty heavily used in the embedded Linux community, and so I'm just curious if somebody on that side should be looking at switching to OSV scanner as opposed to, like, I think they may have rolled their own scripts to look for CVEs, and especially if OSV scanner is kind of a superset of CVEs. Is that basically true?
Yeah, but it depends on the superset. I mean, if only the CV is applied to your project, in my opinion, it's the same. It's the same thing to use a CV scanner and to use this kind of aggregator like OSV scanner. So if I'm using, for example, Rust, maybe I have an advantage in using OSV scanner because I have the Rust scanning already integrated,
Right.
and the vulnerabilities are not published as a CV. But if I'm using, I don't know, Perl, maybe Perl is not integrating in OSV scanner. There are only CV, so I mean I can also use I will only use the CV scanner because OSV scanner will basically generate the same information in the
Okay,
end.
yeah. No, there is a Rust layer for Yocto. I don't know if it's official or not,
Mhm.
but okay, thank you.
Thank you for attending. Please give a round of applause to our speaker.
Test, test. Okay. Yeah. Sounds good. Okay.
Testing. 1, 2, 3. Testing.
Cool. Thanks. At 45. So. Oh yeah. Okay. Cool. Yeah. it's back.
Good afternoon, everybody. Welcome to the security track at SCaLE 21. This presentation is Human versus AI, How to Ship Secure Code. Please welcome your speaker, Xavier.
Hey, folks. First, thank you for being here. I know that it's the last slot, so you made it. Congrats to you. So there has been a slight title change. It's Code Security Reinvented now. So my name is Xavier. I'm French, but I live in Palo Alto, California, with my wife, my 3 kids, my 3 cats, and my 3 koi fish. And I'm working at GitHub, which is the AI-powered developer platform, where more than 100 million developers build, scale, and ship secure software. So there is, of course, a commercial side to GitHub's mission. But you, I hope, all know that there are also sides of GitHub that are not commercial. For example, GitHub Education, where we give resources to students and faculty to learn how to develop software. And of course, everything that we do for open source. And I am on this side. I'm part of this side. I am leading the GitHub Security Lab. It's a team of hackers who find and help fix security vulnerabilities in open source projects. So, disclaimer, I'm not working for GitHub products, so I won't be able to answer all of your questions about GitHub products if you have them. But I will give you the perspective of a user of these products, basically of an open source customer of these products. And so this talk is about the impact of AI on security, and I will illustrate that with what I see in open source. So let's start with the state of open source security. Open source code is everywhere, right? In all the software that is crucial for our lives, whether in transport, medical, defense, finance, open source is everywhere, and we all depend on it. However, there is a lack of security expertise. Some studies say that there is only 1 security professional for 100 developers. And this is a number for global software, right? So you can imagine that it's even worse for open source, where they have less resources. So this imbalance is much worse in open source. In addition to that, there is a disconnect between security and developers. Security experts think that developers don't care about security. And for developers, security is often the department of no. You know, the people who are blocking them, the people who are slowing them down, the people who are preventing them to ship features. This is similar, you know, to the disconnect that we had between dev and ops, you know, before the DevOps movement, right? Where dev and ops were working on competing objectives, innovation and stability. So now it's the same, you know, for security. We have competing objectives, innovation and security. And here again, the situation is worse in open source because these 2 communities are often not collaborating very smoothly, to say the least. So what we need to do, well, we need to shift left. We hear that a lot, right? But what I see a lot happening is people trying to run the traditional security tools and practices earlier in the development process. And that cannot work. These tools and practices are made for the security teams, not for the developers, right? And security teams will be able to understand and to act on the findings, but they are not designed for developers, and they will generate even more frustration and friction between the teams. The best example of that is false positives. Developers hate false positives, right? And just moving these tools earlier in the development process will reinforce the disconnect. If these tools bring a deluge of false positives to developers, developers will have a confirmation that security is the department of no, and they are blocking us for no reason. And you know what happens when you have an alarm that goes off frequently for no reason, well, after a few false alarms, people tend to ignore it. So developers will begin to ignore these alarms, and security will have confirmation that they were right. Developers don't care. So you will have a reinforcement of these wrong assumptions on both sides. So what's the solution? Well, we need to empower developers, right? We cannot just shift left by just moving left these tools and these practices. We really need to give developers autonomy and expertise, right? And that includes, designing the tools for them, for their use cases. But we really need to shift left a culture of security. So this is the agenda for the rest of this presentation. So we show the state of open source security. Next, I will show you what it takes to effectively shift left a security culture, right? What we are doing right now as humans. And then we will see how AI accelerates, augments, and reinvents this. And finally, we will finish with some perspectives. So we will start with talking about what we are doing as humans. It will be a bit boring, and then the robots will come in. So bear with me. So yeah, shifting left the security culture, this is not easy. Encouraging developers to adopt security practices is a bit like encouraging my kids to eat vegetables. Developers prefer to ship features, and they leave the security, to the side of the plate. Well, despite the provocative analogy, I don't believe that developers are childish, and I don't believe that developers don't care, right? I believe that they need to be empowered. So this is a cake that my wife baked for my son's birthday a few years ago. Who can take a guess what's in this cake? No one? Well, chocolate? No, there is a question mark here. So it's not chocolate. It's anything but chocolate. We're looking for a vegetable. No. No. Huh? No. 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 It's worse than that. No. Sorry? It was for 9 years old. Yeah. So, beets, red beets. And the kids loved it. And imagine, 9 years old kids, right? Pretty difficult judges when it comes to food. And they loved it. And my wife was doing this all the time. She was integrating the vegetables into a meal that the kids love. And what does it mean for security and developers? Well, we should try to integrate security practices into what developers love. And what do developers love? Coding. So, my solution to really shift left effectively is to integrate security into the existing practices, into the existing developers' tools, into their existing flow, not in another tool. I want to integrate that into the developer's IDE, into the developer's browser, not into another process. I want to integrate security into the current development process, whatever it is for your organization. And so we talked about vegetables, but this is what worked with DevOps, right? Developers started testing when they could code their test, with XUnit and Fitness and Selenium, etc. Developers started coding deployments with infrastructure as code. So I think this is really the solution for security. Bring the community's expertise into the developer's flow. So now let me show you a few examples of how we are doing that at GitHub and in my team. The first example is how developers can secure their dependencies. So my team maintains the GitHub advisory database. This is an open source information about security vulnerabilities disclosed in open source projects. It's free, it's open source, because we think that vulnerability information in open source is a common good. And because it's open source, we receive more than 1,000 community contributions per year. So this database, originally we take data coming from the NVD, the National Vulnerability Database, from some other sources like RustSec, like PyPy, etc. But we also get community contributions from anyone who has the information and the knowledge and the expertise. We review it in my team, we curate it, and we make it available for everyone. For example, as soon as this denial of service vulnerability is disclosed, it gets reviewed in our advisory database with important information such as the CWE, the CVSS score, and very important, the affected versions and the patched versions. And with that, this information will flow directly to Dependabot. Dependabot is the SCA tool by GitHub, which is free for everyone. And if you're on GitHub, Dependabot will create automatically a pull request in all the projects that depend on WorldWrap if they use one of the affected versions. And so as a developer, I just have to review the pull request and merge it if I'm happy with it. So I have really here knowledge coming from the community and ending up into my developer flow. This is exactly what I would do if I get a suggestion a fixed suggestion in any pull request. You will note that there is a yellow box here with a nice message from Dependabot. Well, it's not nice, it's a bit passive-aggressive, Oh, you're a bad maintainer, you don't care about me, so I will pause my interaction with you. Well, indeed, it's because I kept this alert intact so that I could take the screenshot for this presentation. But more seriously, this feature is another example of how a security tool can try to be less disruptive for the developer's flow, right? Oh, I detect that it seems that you don't care for any reason. I will pause, and I will not bury you under a lot of useless reminders. My second example is how you can secure your code. So at GitHub, we have a static analysis engine called CodeQL that finds security vulnerabilities in your code. It's also free for open source. It takes one click to enable. And unlike the difference with the other static analysis engines is that CodeQL has a very powerful taint tracking to track malicious data through your code. It does it across different functions, across different files, across different libraries, and even through libraries external to your code. For example, CodeQL can detect Log4Shell, the 2021 JNDI injection in Log4j, because it can track the untrusted data from the call to the logger down to the JNDI call. And this data, it flows through more than 150 steps in the code, in more than 10 different files, right? And CodeQL is able to detect it. All of this, again, is free for open source. Yes, question? Yeah, so CodeQL is available for, you can visit codeql.com. You have Java, JavaScript, TypeScript, C, C#, C++, Python, Ruby. I think that's it. And yeah, that's the languages. Yeah. I might have forgotten one or two, but yeah. Yes, wait. And yes, of course, we are trying to implement other languages. It has to be done language per language because how it works is that to be able to do this powerful taint tracking, we really need to adapt each of our data model and our control flow to each language to have something very precise without the false positives that we all hate. Yeah, and CodeQL is what my team uses, for example, for finding vulnerabilities in open source, and you can check our CodeQL Wall of Fame. We find more than 100 vulnerabilities, 100 CVEs with CodeQL on open source projects every year. And this is used also by the community. The second line here they are not in my team. Jordi and Alexandra, they are working at Google Security, but they're using it, and then they can say, hey, we find this CV with CodeQL. So once enabled, you will benefit from hundreds of security checks designed by the GitHub security experts, but also by security experts from the community, because the queries are open source. The code queries are open source. So by just enabling this scanner, you will benefit from this ever-growing expertise automatically without doing anything. And you will basically sit on the shoulders of giants, because our security teams at customers who are using CodeQL and writing, improving these queries, you will benefit from that automatically when they reach the open source repo. And of course, the GitHub team curates these queries so that they have a very, very low false positive rates, because again, we don't want to interrupt developers in their flow, right? So basically you have two kinds of queries that are designed for developers with very low false positive rates, and you have queries designed for security teams, the ones that my team uses, for example, with we care more about false negatives ourselves, so we will have a lot of false positives, but we triage them. So by default, you have the standard queries for developers. Just by adding one line into your configuration, you can also benefit from the security queries sourced from the community. And for my purpose here of enabling, empowering developers, these alerts are displayed in the developer's flow, in their pull request, next to the code, next to the very line of code, right? So I remember this friend who was engineering manager. It was 5 years ago, and he was very happy because his SAST tool was upgrading, and he tells me, hey, you know, the previous version was generating the security alerts in a big PDF, and now it will generate Jira issues, and developers will love it. Well, they did not love it, right? Because, yes, we can all agree that Jira issues, it's much better than a big PDF, but it was not in their flow, right? So instead, here you have the community expertise flowing directly to the developer's flow in their code, in their pull request. You notice also here the link show more details that will just open, you know, more information about the vulnerability, how to fix it, because again, we are speaking also here about shifting left expertise and not only just the security finding. And it works. By bringing these alerts into the developer's flow, by eliminating false positives, we obtain an impressive fix rate. Half of these alerts are fixed immediately when and where they are raised, which is really a testament to the effectiveness of, shifting left really and empowering developers. My last example is this training that my team developed. It's a game. It's a set of challenges to train your developers on secure code. And it's an in-repo game, so developers just have to clone, read code, run tests, fix the code, rerun the tests. And it's open source, so we have contributions from the community who are adding more challenges as we go. So here again, same principle, community powered, because it's open source, and directly usable by developers. It's in their IDE or in their browser, and they are just doing what they usually do as developers. They read code, they test, they fix. So again, an example of community security knowledge flowing at the fingertips of your developers. And when you think about it, this is a perfect use case for AI. Getting the community's knowledge and bringing it to the fingertips of your developers. So now, let's explore how AI can accelerate, can augment this solution, and yes, how it reinvents, really, the way we are thinking about shifting security left. So I will illustrate this exploration with GitHub's pair programmer, GitHub Copilot. I'm pretty sure that some of you forgot, but GitHub Copilot has been around for quite some time now. We announced it in June 2021. And so it was really the first production-ready AI pair programmer. And I want to say loud that it's not here to replace developers, right? It's here to help them be more productive by eliminating low-value tasks, such as writing regex, right? So that they can focus on higher-value tasks, right? This is the goal of GitHub Copilot. And last year, we surveyed 500 developers from Fortune 100 companies about their use of GitHub Copilot. And nearly 90% reported that they were completing tasks faster. But what I find even more important is that 88% say that it helps them stay in the flow. And it helps them focusing on more satisfying work. And this is exactly what we want to do. So, well, I will repeat that throughout the presentation. AI is not here to replace developers, just to make them more productive by accelerating the low value added tasks. So now we are going to explore several ways developers can use AI to leverage the world's security knowledge. And remember, with the same exigence that we stated earlier, we want this knowledge in our flow. We want this knowledge to accelerate what we do and not to slow us down. And yes, a small disclaimer, what I will show now. So what I showed you, the whole GitHub security suite is free for open source, right? But Copilot is not, and therefore the AI features that I will show you are not, right? But again, I'm not in the product team, so I cannot tell you if that will be in the future. So let's get started with writing safer code. Can someone in the audience spot the bug here? It's a SQL injection. Indeed, the user is concatenated directly into the SQL query. So what can happen? Well, the attacker, does it play? Yes, the attacker can put another SQL query in that query and drop users, for example. So drop your table. They can create an admin user with elevated privileges. They can enumerate all users of the table, which can leak private information. Well, so that's a SQL injection, that's bad. But if I delete the code that I've written and I leave it to GitHub Copilot to propose something, the suggestion is safe from this SQL injection. It uses parameterized queries, right? And so the user control value is not passed anymore into this query. Yes?
Security reviewing.
Sorry?
Are you running a form of security scanning for each suggestion from the Copilot?
No. Let me tell you how it works. So how does it work? It's because we added a vulnerability filter on top of Copilot, right? So originally, Codex, the LLM developed by OpenAI that powers Copilot, it's trained on all public open source code available on GitHub. So the suggestions are by default as secure or as insecure as this public code. But we added this filter. This filter is another LLM that is trained on CodeQL, right? And so this LLM is able just to identify the most common vulnerabilities, like path injections, SQL injections. And then identifying these most common vulnerabilities, this LLM is able to remove them from Copilot's suggestions. And so at the end, the suggested code will be safer than the original code that Codex was trained on. Does that answer the question? Thank you. But I will repeat this again. Copilot is not here to replace developers, and Copilot is not here to replace DevOps practices, right? It's even the opposite. I'm saying that GitHub Copilot makes you gain some time writing code. You should do more of DevOps practices. it's an opportunity to do more DevOps practices. Now let's move on to examples of where AI can help us find security issues. So we will see several examples of that. One, finding leaked credentials. Two, finding security vulnerabilities in your code. And three, doing a code review. So in GitHub Advanced Security, the GitHub's security product suite, you have a feature called secret scanning to detect secrets like keys, tokens in your code that you had checked into your repositories. Again, free for public repositories. And this is important because, according to Verizon's data breach report in 2023, use of stolen credentials was by far the preferred way for attackers to breach into an organization. So preventing secrets to leak into public code is going a long way to protect our organizations. 1 million secrets in public code was detected by GitHub's secret scanning only during the first 8 weeks of this year. That's more than 10 secrets per minute. I thought that it doesn't happen frequently, to push secrets in code. Well, I was wrong. It happens all the time. So in addition to detecting secrets when they are already in repositories, we added a feature called push protection, which is a proactive detection of secrets leaked locally. And then when you try to push this commit to a shared branch, then push protection would kick in and would block you and would tell you, hey, no, you are trying to push a secret to this branch. So it will tell you how to remediate that. And so the secret will never reach a public branch in the first place. And this feature was opt-in until now, right? And last year, this feature prevented more than 30,000 secrets to reach public repositories, just last year alone. And so it was opt-in, but given the scope of the problem, we decided to enable it by default. So now it's enabled by default. It's been 2 weeks now. And so you will have to opt out. But by default, we will prevent you to push a secret into a public repository. And back to our topic, how can AI help us here? So all these secrets that we detect in code is because we are partnering with different providers like AWS, for example, AWS, Apple, etc. And we have 180 partners and more than 220 patterns, so regular expressions, provided by these companies that we can detect. But you might still have some custom patterns that you want to detect that are very specific to your organization. And these patterns, you will have to write them with regular expression, right? And, well, we saw in the earlier example that writing regular expressions is not always easy. A colleague of mine was saying that the plural of regex is regrets. And so to make it easier and faster for you, now we include this form, where you have an AI-powered experience that guides you through creating those custom patterns. And so this feature, well, it's not only an incredible time saver, right? But it helps you get the good coverage that you need to make sure that your secrets are secure. We are shipping another AI-powered feature. It's now in public beta, but it's AI-powered detections of passwords. So if you try to use the traditional scanning methods with regex matching, you will have a high false positive rate to detect passwords because they don't have a structure, So we are shipping this new feature where we are asking AI to detect whether passwords are leaked in code. And so far, the results are pretty promising. We have a very low false positive rate. Even with that low false positives rate, what we will do is that we will display these results in a separate section with other low confidence patterns, because the rationale here is that, again, we don't want to block developers in their flow, so we are displaying separately the detections that are high confidence, low false positives, and the findings that are low confidence and potentially high false positives. Again, we don't want to interrupt developers for nothing. Same principle. So that was for secret scanning. Now let's look at finding security bugs in your code. So we talked earlier about scanning your code with CodeQL, our static analysis engine. And now we are shipping a feature called code scanning autofix. So code scanning will now propose AI-generated fixes right in the pull request. It will enable your developers to instantly fix vulnerabilities while they code, right? And we think that it will give an even better remediation time. If you remember, we had a 50% fix rate when the alert was raised in the pull request. We hope that by providing a suggested fix, in addition to the alert, will make it even easier for developers to act on these alerts. And these suggestions will also help developers to quickly understand the vulnerability and how to remediate it. Because they will basically have a concrete example of an insecure pattern, their code, and of a secure pattern with the fix. And so it's also contributing to shift left expertise at the same time. So this is at the moment for JavaScript and TypeScript, but more languages are coming up. So let's see that in action. So here I'm writing a very simple code. I'm personalizing hello world by adding a name. I see that there is a reflected scripting here, reflected XSS in the alerts in my pull request. And then, so of course here you can see where the data flows. So again, there are only 2 steps here, but remember for Log4Shell, for example, it's 150 steps that you could see in there. Okay, and then on this alert, you see that, well, you can dismiss it if you deem that it's a false positive. But now this is the autofix. Autofix will generate a fix for you. The fix consists in sanitizing the user control parameter with this call to escape. And this fix, well, you can edit it, you can dismiss it, or you can commit it directly. You can see that this fix spans across different files, not only your original file, right? It's a proper fix LLM generated to help you remediate this vulnerability. Again, it's right into your pull request, right into your flow, not anywhere else. And it's again an example of securities, community knowledge flowing into your flow. Now let's look at my third and last example for finding security issues, code review. So in my team, so I regularly ask my hackers to find, to audit some open source code that they are not familiar with, right? And so I guess it's also the case in organization when they ask security teams to audit some code that they don't know about. So I can use GitHub Copilot Chat, which is available through GitHub Copilot Enterprise, to describe the attack surface of a project. Right? So the attack surface is the number of possible attack vectors where an attacker can access and abuse the system, right? So entry points to the system, locations where there are accesses to assets of the system, right? So here I'm asking the attack surface, and I get an answer from Copilot Chat telling me the different entry points, the different points in the code that I should look at. You can note that it first starts telling me, hey, I won't perform the audit for you. Yes, of course. Once again, it doesn't replace you. It just accelerates the process. It kind of quick starts the process. So now my hackers, for example, what they were doing before, they were looking at the documentation, and then trying to find their way, okay, what would be interesting? Oh, there is a database, okay, so I will look at that. Now here, it just accelerates this process. this is another example of the same thing. And I used for that our secure code game repo, which is intentionally vulnerable. And yeah, I was happy here that Copilot was able to tell me, oh, you know, you're using a database, so you should pay attention to SQL injection, you should pay attention to untrusted inputs, you should pay attention to managing elevated privileges. And now my last example is for developer learning. As we said, shifting left is also giving autonomy and expertise to the developers, not only the tooling. So let's see this example. I wrote some code, and again, you can see that there is a SQL injection in that code because stock symbol is controlled by an external user and is concatenated directly into the SQL query. So I'm a developer, let's say I'm a junior developer, and what do I do after writing the code? Well, I'm asking for a code review. So let's ask GitHub Copilot for a code review. And immediately, GitHub Copilot tells me that there is a SQL injection in my code. Okay, but what is a SQL injection? I don't really know, you know, I'm a junior developer. What is a SQL injection? So I'm asking, and I will get an answer immediately that is not super helpful. I mean, I could get that from Wikipedia, right? But it's not helping. What I need is really to understand the consequences of the SQL injection, and I need to have that knowledge tailored on my code, right? This is how I will be really able to grasp completely what this SQL injection is about. And so I will get a clear answer here telling me, okay, yes, stock symbol is user controllable. You can add, you know, or 1 equals 1 to that, and it will enumerate all of your database. I can ask other, but again, this is really tailored to my example, to my code. So I can kind of test it and see it, right? I can ask clarifying questions. So here, what am I asking? Yeah, can this attack be used to damage my database? Okay, and yes, of course, if the user adds drop users to drop table to the external symbol. So this is a way where, and only then, you know, only after that, when I understand, I can ask for a fix, right? But I just don't, you know, get a fix and apply the fix. I get expertise in addition. And this expertise is really useful and concrete because it's tailored to the context, to my code. Okay, so what did we see here? We saw how developers can use AI to leverage the world's security knowledge through several examples, but what I want to point out is that we saw examples spanning through the entire development process, right? We saw examples with coding, with code review, with test, and even with learning. Now I'd like to conclude and give also some other perspectives. So yeah, I think that for me, it's pretty obvious that AI is reinventing developers day to day, including secure coding. And yeah, from the survey that we had last year, yeah, 92% of developers surveyed are already using AI tools at work or for their personal projects. So it's there, right? And I want to repeat again that AI is an accelerator. It will not replace you, it's an accelerator, you know? And you will spend less time typing, you will spend less time searching the internet, and it's an opportunity for you to have more time for security, quality, design, learning. You know? And the good news is that from the same survey, this is exactly what developers want. They say that if they had if they were using AI coding tools to gain time, then they would like to use this time to focus more on code reviews and security reviews. Well, that's good. Now, every new technology breakthrough comes with positive and negative consequences, right? So this talk would not be complete without exploring the dark side, right? So I would just tell you the two questions that people ask me the most. The first one is, can Copilot reinforce insecure coding practices? And the second one is, can Copilot leak my private code to the public? There are others. I trust you to ask them after the talk, but these two are really the ones that are the most asked. So it's a very legitimate question, right? Copilot is trained on public open source code. This open source code can be insecure. And Copilot relies also heavily on your surrounding context to tailor its suggestions. Therefore, you know, if you have a lot of insecure code in your team or in your project, then it's natural that Copilot suggestions will be how can I say, tailored to that and will give you insecure suggestions. But, well, this is not new, right? This is already happening before Copilot. A junior developer getting into a team or on a project, the junior developer would be also heavily influenced by the surrounding code. They will learn from the surrounding code. They will copy-paste from the surrounding code. So that was already existing before Copilot. So 3 considerations for you is that, first of all, it was existing behavior before Copilot, but now Copilot will do it faster. That's half a joke, because we will see later that it does that for secure code, for insecure code, but faster. The second thing is that, well, actually it's not true. It's a lie, because we have this vulnerability filter that we apply on top of the suggestions. So this vulnerability filter removes the most common security vulnerabilities. So at the end, the code generated by Copilot will be safer than your original context. And finally, why the first point was half a joke? Because if you're going faster, use this time to do more DevSecOps. Use this time to do more design, more learning, more testing. You must not use Copilot without DevSecOps practices. Imagine the following scenario. You're a junior developer coming into a team, and in this team, there is a piece of code you're working on where there are a lot of insecure patterns. You're using Copilot, and thanks to the vulnerability filter, the code suggested by Copilot is secure. The code that you're writing with Copilot is secure. Okay. But then, during the code review phase, you have a colleague who tells you, hey, don't reinvent the wheel. I've already coded something that does exactly that, so reuse it instead of reinventing the wheel, which makes sense. But then at the end, by doing that, you will become insecure. You will use this insecure code, right? So again, if you are using the gain time to do more DevSecOps, to do more learning, then you will hopefully prevent this scenario to happen. So the second question that I get asked is whether Copilot can leak your private code and make it public. Because if you use my private code as training data, eventually suggestions to external users can end up in public code. So GitHub Copilot for Business does not retain any prompts. So you know, in the prompt, there will be your prompt. There will be also the surrounding code. And all of this prompt will be sent to the model. You will get back the suggestion. The prompt is not retained. It is discarded automatically just after a suggestion is returned. So no, your private code cannot leak to a public code. But there are more questions, of course. Again, I repeat that it's a new technology breakthrough. People have a lot of questions, and they are legitimate. So we created the Trust Center, the GitHub Copilot Trust Center, with dozens of frequently asked questions related to security, privacy, transparency. just such as the one that I just answered. And again, these questions, they are legitimate. A lot of people are asking them, so you can go to this page. This is a great resource to understand what is happening with your data when you use GitHub Copilot. Finally, so this talk was focused on how AI can reinvent code security, but it's only a small portion of what AI can help with when it comes to security. Software security is much broader, and we can anticipate a lot more applications of AI for software security, right? For threat intelligence, penetration testing, malware analysis, security operations, incident response. My team is also using it for code security to improve fuzzing. For example, they are using coverage data, identifying gaps in the coverage, generating new fuzzing harnesses, and then closing the loop with that. So yeah, certainly a lot more to come when it comes to how AI can help security. So that's the end of this presentation. So you can follow us on X with the GitHub Security Lab account to get more information about what we are doing for open source security. And you can also follow me. Thank you for staying for this last slot of the conference. I appreciate it. And yeah, if you have questions, I'm here. Yeah. Thank you.
Thank you for your presentation. I have a couple questions. First of all, is the developer learning is part of the code? It has to be in the GitHub ecosystem. This is built in that ecosystem, right? Your Copilot thing, right? We can't access, like for example, if I don't want to use GitHub, I just want to use the developer learning, I can't, right? You have to use GitHub on the back end, right?
So what I showed was with GitHub Copilot, but well, I know there are competitors out there who are also doing. Well, I know they are at least doing code completion. I'm not sure if there are. Yes, I'm pretty sure that you're not bound to that. I showed example with the GitHub platform, but I'm pretty sure that in principle, having this kind of developer helps where you can chat with a bot to get community expertise right in your flow. I think that's a principle that I want to push, but right. I'm not aware of other solutions.
Okay, and one more question is, the code QL, you said it's open source, right?
The queries are open source. So CodeQL, you have the engine that run the queries on your code, and you have the queries, and in the knowledge, if you want, resides into the queries, because this is where a security researcher will say, oh, this pattern is insecure, let me code it. So all these queries are open source.
Okay, so I still need to go, like I still need to use GitHub, right, for this?
So
or
do you have
a
public
source.
repository?
Huh?
Is it a public repository that you have?
Okay.
Public open source?
So for example, if I use Bitbucket, which is Git on the back end, I wouldn't be able to use the code QL, right?
Is your project open source and public?
No, it's not. It's
private, so no.
Okay, so if I use Bitbucket it's a public, I would be able to use
yes,
CodeQL. Okay.
Yes. CodeQL is free for all public repositories, even if it's not on GitHub. But if you're on GitHub, you will benefit from the integration, and the alert in the pull request, etc.
Yeah.
But if you're not on GitHub, and you have a public repository, you can still use CodeQL on your code. Yes.
Got it. Okay.
So for CodeQL, you have a nice feedback cycle, in my opinion. For example, if you are a security engineer, you can publish the queries via GitHub, and you can maybe get a bounty for that query that you can get, and basically the entire open source ecosystem is improved. Do you also plan for something like this for the AI-based patches or the AI-based vulnerability detection for example, myself as a security engineer to publish some patches which are correct, or to publish some vulnerability detection patterns?
No, no, we don't. It's yeah, it would be a nice addition. Yeah.
I guess I have two questions. The first is, what is your stance on people hard coding test tokens or other sort of invalid tokens? And from like a machine learning model perspective, I find those are hard.
Sorry, I don't hear very well. But no, I think it's because of the noise.
Okay. So my first question is, what is your stance on hard coding test tokens or secrets? And from like, are those considered false positives? And because for ML models, I feel like they're very hard to distinguish those types of tokens that are structurally the same as a real token, but sort of the context in which they're used, sometimes people want to hard code those for particular test reasons. And then the second question is there any application of using ML models to detect general sensitive data, like personal user information or other things, beyond just secrets?
Okay, so the first question was about how, well, my stance on these detections that are detecting a lot of false positives.
Or just
right,
like, are test tokens or test secrets considered false positives, or are they like considered real detections? Like, what's your stance on whether people should be adding these to repositories or not?
It depends. It depends. I mean, I know that we have some secrets that are only for tests and that are not doing anything, and we can add them, but it will be detected by the secret scanning, and then the developer will be able, to say, no, I dismiss, it's a false positive because blah, blah, blah. And you have the possibility to do that, right? My personal stance is that, this secret, if you have another way to to do that, it's better not to add it in there, right? Because it's also kind of a habit, Yeah, no, don't push secrets in there. Find another solution, right? Oh, it's only for tests. Oh, it's only a very limited secret to that. Perhaps, yes, but I mean, if you can find a way to do it in another way, please, no, do it in another way. That's my stance. But the product gives the possibility to have this case managed. You can say, no, it's a false positive, it's okay. And then the second question was?
Just about using AI or machine learning models to detect general sensitive data like UII or personal identifiable information beyond just secrets.
So using ML to detect.
Oh, yes, yeah, that's interesting. So this is something that so again, I'm not in product, so I cannot tell you if we are looking at that too, but I know that it was flowing like, okay, a secret, what is a secret, right? So I don't know, but I know that it was floating into discussion, in discussions.
So is this integrated tightly into GitHub? So if I was using a Git repository internally, is there a way for me to use the AI?
So the AI, no. Secret scanning, no. No. Well, I mean, but CodeQL, for example, you can use it for any public. So advisory database, it's open source. You have an API. Yeah, you can use it for everything. Yeah. So yeah, it depends. But the AI, no. Your question was specifically for the AI part, yeah? No, CodeQL you can. CodeQL it's free for public repositories. So, and you can also buy it for private repositories. Right? Yeah.
The previous presentation talked about CodeQL. He's sitting right here. If you want to learn more, sit
I know I have a lot of questions, but
it's okay.
maybe other people. I did not understand why you said Copilot is reinforcing the insecure code. Now, were you saying that people were thinking, no, I don't have to learn how to write secure code? Is that why or is it something else? why is it why are people saying it's reinforcing
Yeah.
in secure code if it
Yeah.
provides
So, well, it's,
all this stuff?
so I don't know why they are asking that, but it's a question that I get asked a lot. I think that they might have read that somewhere, but when you think about it, it's normal, right? Because it's influenced by your surrounding code. If you are on a project in a team, if you have code that you already wrote that was insecure, it will automatically say, oh, I will try to adapt my suggestions, to prioritize my suggestion to match this style, for example, you know? And doing this, if you have wrote a lot of insecure code, then it will give you insecure code. You know, that's insecure in, insecure out, right? So that would be by default, but fortunately we have added this vulnerability filter on top that removes the insecure suggestion and hopefully, you know, breaks the vicious circle and improves.
Thanks. I also like your last bullet saying about the privacy, because, you know, as security engineer, we're always concerned about.
Yes.
I don't want to let people know what
Yes.
you know the stuff I have. So that was good. Like you said, the stuff in your repository is private, right?
Yes.
Okay.
Yeah.
And that's important for us.
It is
and
important.
One more thing I want to add. I like how you repeatedly said AI is not going to replace developers, or AI is not going to replace.
Did I repeat it enough, or?
I like how you said it repeatedly. Hopefully that's true. Oh, I'm sorry. Not appropriate. All right, thanks.
Let's give it applause for our
Thank you.
presenter.
Thank you all.